there. Guess what? I learned something new in class today. It's called integral calculus. Well, basically, it's a powerful mathematical technique that helps us understand how quantities accumulate and change. Well, what is integration? Well, integration is essentially the opposite of differentiation. While differentiation breaks down a function to understand its rate of change, integration helps us understand the total accumulation of quantity. Well, to help you understand and to make it simple, let me illustrate this with a simple example. Imagine you're tracking down the speed of a car. Differentiation tells you the car's acceleration at any moment, but integration tells you how far the car has traveled over time. First is the constant of integration. When we integrate a function, we always add a constant to our solution. This constant represents the infinite number of possible antiderivatives for a given function. So, let's try this with an example. Let's try to solve this example.
For the first example, we have to solve for the derivative of dy over dx is equal to 3x squared at the given point of 2 and 10. So first we have to find the antiderivative of 3x squared. So the antiderivative is y is equal to x cubed plus c. Then to find, we have to solve for the constant, this constant right here. And we can solve this by substituting these values in this equation. So we're gonna have 10 here, 2 cubed plus c. Then this is gonna be 10, this is gonna be 8, and this is c. So we can subtract 8, we can move 8 to the other side, and then it will be negative, so we'll be subtracting it by 10, so the value would be 2. So 2 is our value for the constant. So we're not gonna stop there yet. We have to input the constant's value so that we can have the final answer. So the final answer, we can achieve the final answer by simply adding the value of c in this equation. So it would be y is equal to x cubed plus 2. And that is your final answer. So we have the next example. So find the equation of the curve that passes through 3 and -2 and has the slope of dy over dx is equal to 2x minus 3. So the points are 3 and -2. So first is we have to find the antiderivative. So the antiderivative would be x squared minus 3x plus c, y. Okay, then we have to find the value of the constant. So how do we do that? We can do that by simply substituting these values to our equation right here. So this is gonna be -2 is equal to 9. Oh wait, it's gonna be 3 squared minus 3 times 3 plus c. This is gonna be 9 minus 9 plus c. This is gonna be negative 2. Therefore, we'll have, so these two will cancel out, so we can't move them to the other side since it will still be 0. So we'll have the value of negative 2 for our c. So yeah, so to find the final answer, we'll have to just substitute the value of c in this equation. So let me erase this. And our final answer would be y is equal to x squared minus 3x minus 2.
So now that we're done with the constant of integration, let's move on with the area under the curve. So the area calculation involves integrating a function. The areas can be either positive or negative depending on the curve's position. Let's take this graph for an example. If the area is located up here, the area is positive, while if the area is located down here, the area is negative. How about let's try solving a problem involving area under the curve?
For the example we have, find the area under y is equal to x squared from x is equal to 1 to x is equal to 2. So first step we have to do is we have to compute the definite integral. So we can do this. A is equal to, no, sorry. So you have 2 here and 1 here. Then we have x squared dx. Then here we'll have x cubed over 3, 2, and 1. So this is our definite integral. So let's proceed. We have to evaluate the bounds. So we can do this by substituting the values, or yeah, we can use the formula. So we'll have a is equal to 2 for 3. Okay, let's erase this so you can have space. So let's evaluate the bounds. Gonna be 2, 3 over 3 minus 1 cube over 3. This will have the value 8 over 3 minus 1 over 3, and we'll have 7 over 3 units squared. So this is our final answer. So next, for example number 2, we have, let's find the area under y. Y is equal to 3x from x is equal to 0 to x is equal to 2. So again, we have to find the definite integral. So the definite integral of this equation would be 3x squared over 2 and 2 and 0. So again, we have to evaluate the bounds. So therefore, this will become 3 times 2 squared over 2, then 3 times 0 squared over 2. So we can see that this will become 3 times 4 over 2, since this will be 0. To simplify, we'll have the value 12 over 2, or we have simply 6 units squared.
Next is the definite integral. What is a definite integral? Well, it represents the total accumulated change. It calculates the net area between the curve and the x-axis, and it provides a precise numerical result. Let's try this with an example.
So we have to evaluate this equation. So to evaluate this equation, we have to first find the antiderivative. So the antiderivative would be x is equal to 4 over 4 plus c. So next is we have to evaluate the definite integral. So we can do this by simply substituting these values and subtracting them. So we have 3, 4 minus 1 to the power of 4 over 4. Then we have 81 over 4 minus 1 over 4, 80 over 4, and 20. So this is our final answer. So for example number 2, we have to evaluate this equation. X squared plus 3x dx. So we have to find the antiderivative, which is x cubed over 3 plus 3x squared over 2. So this is gonna be quite long, so let's erase all of them. You can take a screenshot if you want. So we have to evaluate the definite integral by substituting the values. This is gonna be 8 over 3 plus 12 over 2 minus 1 over 3 plus 3 over 2, 8 over 3 plus 6, and we have 1 over 3 plus 3 over 2, with the final answer of 41 over 6.
Whew, that was a lot. But integral calculus can also be applied in real life, such as in physics for work and energy calculations, economics, total revenue prediction, and engineering for the volume and accumulation problems. That is basically it. Calculus is everywhere. You can apply calculus even when you're walking down a street, when you're helping someone, when you're talking to someone, and even when we're not students anymore. And that is all. I hope you learned a lot. And thank you for listening. Bye, friends!